Alright, we are starting Chapter 6 in Algebra, and we are looking at probability. So we're going to start out with some vocabulary. You just want to copy these each down. First one is the fundamental counting principle. If an event M can occur in M ways, and is followed by an event N that can occur in N ways, then the event M then can occur in M times N ways. We'll do plenty of examples with that later. Sample space is the set of all possible outcomes, and an outcome is the result of a single trial. Feel free to pause the video if you need more time. An event is one or more outcomes of a trial, and it is a subset of the sample space. Independent events are when one event does not affect the other event. We'll do lots of examples with those, as well as with dependent events. And that's when one event does affect the outcome of another event. Compound events is an event that's made up of two or more simple events. Mutually exclusive events are when two or more events cannot happen at the same time. And that's all for our vocab. So now let's go ahead and get started with the fundamental counting principle. I'm going to skip the explanation and jump straight to the example because I think it's easier to see using the example. For a breakfast special at the country pantry, customers can choose their eggs scrambled, fried, or poached. They have the option to order whole wheat or white toast, and they can get either orange, apple, tomato, or grapefruit juice. So how many different breakfast specials can a customer order? And so what we're going to do is we're going to take how many options they have of each of these and multiply them together. And that's what they're doing down in the little solution here. There's three ways to choose your eggs. You can have scrambled, you can have fried, or you can have poached. There are two ways to choose your toast. You can have either whole wheat or white toast. And finally, there are four ways to choose your juice. You get the orange, the apple, tomato, or grapefruit. And so the rule that we're learning here, the fundamental counting principle, says that you take your 3, your 2, and your 4, and you multiply them together, and you're going to get 24. And so there are 24 different ways to choose the breakfast special, and that would be your answer to this problem. Going down a little further, we're going to take a look at something called tree diagrams, and that's the way that you can sketch out the different possible outcomes. So for example, if we had to make a tree diagram from the problem above here, I would go ahead and start out with eggs, and I would list the three different types of eggs that we have. We have scrambled, we have fried, and we have poached. Now let's just say that you chose the scrambled eggs. From there, you could choose either wheat or white toast. So you have two options from there. And then let's go ahead and say we pick the wheat toast. You would still have four juice choices from there: the orange, the apple, the tomato, the grapefruit. Now let's take a different branch. Let's say we have scrambled eggs, but we choose white toast. Again, we have four juice options. Going down, let's say we change our mind, we don't want the scrambled, we want the fried eggs. We can choose again between wheat and white. And again, for each of those, we have four juice options. And finally, for the poached, we have wheat or white toast, and for each of those, four options. And if you count this up, 4 times 6 is going to be 24. It's going to be the same answer we got up here for the total number of ways. But this is a way to see what all the possible groupings are. Take a look at independent events. It's the outcome. An outcome is the result of a single trial. For example, if you flip a coin, you have two possible outcomes. You can have either head or tails. And the set of all the possible outcomes is called the sample space. So the sample space for the coin is heads or tails. An event consists of one or more outcomes of a trial. The results of rolling two dice are called independent events because each roll does not affect each other. So what we're looking at here is independent events, two things that occur and they don't affect each other. So let's start with one example. Greenmill offers small, medium, or large pizzas with 12 different toppings available. So small, medium, or large pizzas and 12 different toppings. How many different one-topping pizzas do they serve? Well, from here we see there are 3 different sizes and there are 12 different toppings. And since it's an independent event, we're going to take those two numbers and multiply them together. So 3 times 12 is 36. Next one, the cafeteria serves 5 main dishes, 3 salads, and 4 desserts. How many different meals could be ordered if each has a main dish, a salad, and a dessert? We're assuming that if you pick a certain main dish, you're not forced to choose a certain type of salad or a certain type of dessert or anything like that. And since the outcome of one event doesn't affect the others, it is an independent event. So we're going to take these 3 numbers here and multiply them together. 5 times 3 times 4 is going to equal 60. Next one, we have a green die and a red die are rolled. Find the number of outcomes for rolling 2 odd numbers. If we start with our green die, you have the possibility of a 1, a 3, or a 5 to get an odd number. And same thing with the red die. So how many outcomes are there for rolling 2 odd numbers? If you have an odd number here, there's 3 ways to do it. If you have an odd number here, there's 3 ways to do it. So I'm going to take 3 times 3, and you get 9. Now we're going to look at dependent events. This is a little bit different than independent. When one event does affect the other event, it is a dependent event. So for example, this first one. A musical group has been practicing 10 songs, but there's only time for 5 of them at the contest. How many different orderings of 5 songs are possible? And we're going to use the fundamental counting principle to calculate this. So the first song, since they know 10 different songs, when it comes time to choose the first one, we actually have 10 choices. Give me that red marker there. We have 10 choices. However, once we've picked our first song, we have to cross that out. And now, for the next song, there's only 9 more options left because we already used up our first one. So by the time we get to our second song, we only have 9 options. Again, we cross that out. And for our next one, we're left with only 8 choices, and so forth. And we go all the way down until we fill up all 5 of the available slots for songs to sing at the concert. And now we have them filled up. And again, just like independent events, we're still going to multiply these numbers together. And so that's going to equal 30,240. Very large number. When you start to get into things of how many ways can you order numbers like 10, you're going to get in the many thousands, sometimes in the millions. Let's take a look at this for the independent events and multiplying probabilities. This time, instead of having whole numbers where we're counting ways to do it, we're going to have fractions because we're doing probabilities. When you roll a die, an event such as rolling a 2 is called a simple event because it's one event. You roll the die once, and you get a 2 or you don't. An event is made up of 2 or more simple events, and that makes a compound event. For example, the event of rolling an odd number or a 4 is a compound event, and that assumes that you roll twice here. So one roll would be for the odd number, one roll would be for the 4. Because it's made up of the simple events of rolling either 1, 3, 5 or rolling a 4. The fundamental counting principle method holds in this case as well. So let's take a look at this. The probability of rolling an odd number on a die, there's 6 numbers, 3 of them are odd, is going to be 3 and 6. Probability of rolling a 4, well, there's only one 4 on a die out of 6 sides, so it's only 1 out of 6. And again, we're going to take that same idea of multiplying things together. And we're going to take our 3 6 times our 1 6, get 336, and reduce it to 1/12. Now you can do that in your head if you want, or if you prefer to use your calculator, that's fine. So that means the probability of this compound event, which is rolling a odd number or rolling a 4, is going to be 1/12. Moving on here, a die is rolled 4 times. Find the probability of each event. First one, the number 1 is rolled, then a 3, then a 2, then a 3. What's the probability that that will happen? Let's look at each event separately. What's the probability of rolling a 1? It's 1/6. Also, if you notice this notation here, P of 1, whenever you see this P with something in the middle of it, you're saying the probability of something happens. So the probability in this case of rolling a 1 is 1/6. And you'll see that all over the place with probabilities. Going on, the probability of rolling a 3 is also 1/6 because there's only 1 3 on the die, and there's 6 numbers, so 1 out of 6. Same thing with the 2, and same thing with the second 3. There's a 1/6 chance of getting any number on a die. So what we're going to do is we're going to take those 4 numbers and multiply them together. So 1/6 times 1/6 times 1/6 times 1/6, and that equals 1 over 1,296. Next problem, we have 2 odd numbers are rolled, then a 5, then a 6. So let's do this one at a time. Probability of rolling an odd number. Also, you'll notice this notation here. I put in whatever is convenient to say. So in this case, it was probability of rolling a 1. Here, probability of rolling an odd, doesn't need to be a number, is 3 and 6. There's a 3 and 6 chance of rolling an odd number. Well, we repeat that. Probability of rolling the second odd number is the same, hasn't changed. Probability of rolling a 5 is 1 out of 6, and probability of rolling a 6 is 1 out of 6, because it's just one number. So we take those numbers, we multiply them together, and we get 1 over 144, if you simplify your fraction. Finally, a box contains 5 triangles, 6 circles, and 4 squares. If a figure is removed, replaced, and the second figure is picked, what's the probability that a triangle and then a circle will be picked? You'll notice some of this language here. If it's removed, replaced, and then a second thing is taken out, the reason they make a big deal about saying that something was replaced is because when we get to the next section, they will pull something out of the group and leave it out, and that will change the probabilities. So whenever it's replaced, you're usually dealing with independent events. So if we have 5, 6, and 4, that means we have a total of 15 items in the bag. So what's the probability of pulling out a triangle? Well, we have 5 triangles, and we have 15 total things in the bag, so it's 5 out of 15. Same thing with the circle. We have 6 circles out of 15 total, so we take probability of the circle is 6 out of 15. We take those 2 numbers, since they're independent events, we multiply them together. 30 over 225, which reduces to 2/15.